Hello everybody, I am Bùi Phú Thành. My student ID is 2023-1530. Today, my topic is what will an electrical equipment engineer look like in 2030? To answer that, I read 10 real job postings from foreign invested companies operating in Vietnam. Bosch, Schneider Electric, Intel, Renesas, Panasonic, Hyundai, Cafico, Westlake, Cobelco, Kindle, and Le Champ. These companies are hiring in Vietnam right now, so the requirement reflect what the market wants today, not a prediction. My lens is an electrical equipment specifically engineer who work with transformer, motors, and protection relays. That's different from a power system engineer who work with a grid as a whole, power flow, dispatch, and entire network. This talk stay on the equipment side because that is my specialization at Hanoi University of Science and Technology, and because a narrow scope it would let me pull a clear pattern out of just 10 postings. On method, I code each posting for 3 things: job title and scope, any name, tool, or standard, like PLC, FMEA, Verilog, HDL, and any non-technical requirement. The 10 posting collapsed into 7 groups, and across those 7 groups, the same requirement kept resurfacing. 10 posting is a small sample. This shows a trend, not statistical proof. So, with the scope and method set, let's look at what these 10 postings have in common. The core finding. Here is the headline result. Not one of the 10 postings asks for equipment knowledge alone. Every single posting adds at least one of the requirements that go beyond the equipment itself: operational data, proving quality at scale, digital system, applying the same skill in a new setting, or the process and documentation work that surrounds the equipment. 0 out of 10. That's the finding this talk is built around. Electrical equipment engineer is easy to picture as someone whose whole job is knowing how a transformer or motor works. But in every posting, that knowledge is the starting point, never the whole job. 4 of the 10 postings are open to fresh graduates, like Hyundai, Cafico, Panasonic, Renesas, and Kindle. So entry into this field doesn't require years of experience first, it requires the right layer of competency, which the next 2 sections map out. 4 patterns of real work. I grouped the 10 postings into 7 clusters, and across those 7 clusters, 4 patterns keep repeating. In pattern 1, we have data-driven maintenance. Both asks for predictive maintenance and failure chain analysis. The job isn't fixing things after they fall, it's reading data pattern to catch problem first. Westlake named the tool directly, PLC proficiency, specifically on Schneider and Siemens platform. In both cases, the day-to-day work centers on logs, trend, and signal, not just the physical machine. Pattern 2, structure quality control. Hyundai Cafico named control plan, FMEA, failure mode and effect analysis, and SPC, statistical process control. FMEA and SPC are in paperwork in the narrow sense. FMEA is the risk analysis method. SPC is the real-time statistical monitoring of a production line. Documentation is only one piece, the other is active analysis. The posting just say manufacturing engineer, but Hyundai Cafico is an automotive parts supplier, so this quality stack is almost certainly there to prove equipment safe and consistent enough for an automotive equipment production line. That's my inference from the company, not posting own work. Either way, this is a genuinely separate skill from selecting or building equipment. You can know a machine perfectly and still not know how to run the quality system a line audit required. In part 3, we have embedded digital design. Renesas hired for Verilog, HDL, and FPGA design, designing the chips. Panasonic hired engineers to write firmware for refrigerator and washing machine, the code that run on that chips. A decade ago, this kind of work started outside the electrical equipment engineer's job description, but today, Two of 10 posting are built entirely around it. We have cross-industry transfer. Kobelco posting is for power system and control system, but not in a factory. It's for wastewater treatment and waste incineration facilities. The underlying work, like selecting, designing, integrating equipment, doesn't change. Only the setting does. It's the clearest case of skill crossing into a genuinely different engineering sector, not just a different building. It shows the telling of where this specialization can go. In another group, for a different reason, a high-volume manufacturing pressure is neither high for electromechanical design under geometric tolerancing, switches and sockets via a formal product evolution process. The factory floor setting such high-volume pressure through the posting itself doesn't use that term. Intel does. It's named high-volume manufacturing outright. On the test engineering side, where process robustness is what stands between a tiny defect and a large loss of scale. Technical self. Lesham hired a technical self engineer, connection technical knowledge directly to market demand. Site supervision and scheduling. Camden hired for construction site supervision, reading electrical drawing, managing the construction schedule, material estimation on site. It's one of 4 postings are open for fresh graduate, alongside Renesas, Panasonic, Hyundai Cafico, but even here, the job is defined as much by schedule and documentation work as by electrical knowledge. None of the 3 fit the 4 patterns above, but all 3 confirm the same idea. Knowing the equipment is necessary everywhere, but sufficient nowhere, not even in an entry level. 4 pattern, 7 group covering all 10 posting, 1 shared thread. The equipment itself is only ever the starting point. 4. The competency model. These 4 patterns consolidate into a 4-layer model. I built it this way because each layer answers a different question. Being strong in one tells you nothing about another. Layer 1. You have equipment fundamental. What is equipment? Static knowledge like construction, rating, and operating principle. Layer 2. Data and digital core. How does the equipment communicate with the operator, or how is its digital core built? Fault log, sensor data, PLC logic on one side, like both and was like chip and firmware design on the others. I'm grouping them because both go past the physical machine into something electronic layer on top of it. But reading a machine-like data and designing its chip from scratch, it's a genuinely different skill. I'm treating them as one layer for simplicity, not claiming they are not interchangeable. In layer 3 is the quality and process management. How do you prove the equipment reliable enough for mass production, or manage it is a project on site, FMEA, SPC, control plan, but also on construction schedule and material estimate, where Camden fits in. It had almost nothing to do with the equipment itself. It's risk and project management at scale. In layer 4, we have cross-sector application. Where else can this equipment be used? Kobelco is the clearest example. The same skill set applies somebody nobody think would automatically think to apply it. Wrapped around all 4 is a soft skill layer, English and pressure tolerance. English is the single most frequently named requirement in the dataset. 6 of 10 posting ask for its explicitity, more than any one technical tools, because almost all technical documentation is written in English. Working under pressure show up in less often clustering around roles with hard deadline, production ramp-up, testing machine maintenance on-site, construction supervision, a secondary but real pattern, not the universal one English is. One thing to stress: these 4 layers are largely independent. Like Renesas is strong on layer 1 and 2 but say nothing about layer 3. Hyundai Cafico is strong on layer 3 but doesn't touch layer 2. That independent is why I kept out 4 separate layers instead of one generic equipment knowledge category. A single category would hide the real differences in what the company tests for and made it harder to see where my own preparation is strong or weak. So we have the gap with training. Now it's a personal part. How does my program at Hanoi University of Science and Technology match this model? Layer 1 is well covered. My coursework, machine, transformer, protection and switching equipment maps almost directly onto what this company asks for. The one layer where degree and job market are already aligned. Layer 2 is only partly covered. PLC and industrial automation are required courses, matching the Westlake requirement. But embedded programming and microcontroller, what Panasonic and Renesas asked for, aren't part of my track official curriculums. They exist elsewhere in the wider electrical engineering program, just not in my specialization. A real gap close to self-study, not scheduled coursework. Layer 3 has a real timeline attached, not open-ended one. At bachelor level, there's no direct course for FMEA or SPC style quality control or construction schedule and site management work. That's part of the gap it grows. But I am continuing into the professional engineer check. After the bachelor degree, so and its core block explicitly include management, construction, and project operation knowledge, plus a mandatory enterprise semester, a term spent directly inside an industrial site with a capstone tied to an actual company problem. So layer 3 is in the gap with no formal path. It's the gap that closes later. At the engineer level, roughly 1.5 years after layer 1 and 2 are solid. In layer 4, I am deliberately not listing a gap for. It isn't something to train for directly, it's what happened on layer 1 and 2 are solid enough to carry into a new setting. Not a fourth gap, but the payoff of classing the other 3. So, one layer solved by my bachelor degree, one half solved later at the engineer level. Laying this out this way turns something vague. Am I prepared? Into 3 specific answers, each with a specific action attached. The road to 2030. 3 milestones, 1 target. My target is an R&D role at a large FTI company. By creation in 2027, finish IELTS to a level sufficient for technical reading and interviews. Steer my capstone toward design and verification, not just selection existing equipment, targeting the microcontroller and embedded programming gaps. Look for an internship inside an R&D or design department, not just a manufacturing floor. This is where layer 1 and layer 2 get solid. Layer 3 isn't part of this milestone since it isn't taught at bachelor level. Between 2027 and 2029, continue into the pro-eng track. This is where layer 3 actually closes through the program core block covering in project management and construction knowledge, plus a mandatory enterprise semester inside a real industrial site. I'll keep sharpening practical technical English alongside it. By 2029, graduating from professional engineer, move into a formal R&D role with competency across all 4 layers to design and verify an electrical equipment product from the ground up, not just operate or maintain one. The order is deliberate. Foundation and language first, formal layer 3 turning second, R&D role last. It's a prerequisite for the next. The conclusion. Not one of the 10 postings asks for equipment knowledge alone. Not the most advanced posting, not even the zone who open for a fresh graduate with 0 experience. That's not just a research finding, it's the rule. I'm building my next few years around specializing in equipment only pay off pair with the flexibility to apply it somewhere new. Thank you all so much for your attention throughout this presentation. I truly appreciate you taking the time to listen. and I'll be happy to answer any question or hear of your thought now.